Hello everyone. Today we dive into one of the most mind-blowing mysteries in the entire history of astronomy, a star that appeared to be older than the universe itself. This is not science fiction, not a wild conspiracy, but a real, verified, cosmic object that has puzzled NASA scientists, Hubble astronomers, and astrophysicists for more than a century. Its name is HD 140283, but you know it better as the Methuselah star, named after the longest-lived figure in ancient lore. A celestial relic that sits just 190 light-years from Earth, close enough to spot with basic amateur equipment, yet so ancient. It holds the keys to the first moments after the Big Bang. For nearly 20 years, this unassuming star created a paradox so severe, it made experts question whether our entire model of the universe's birth, evolution, and age was fundamentally wrong. Imagine holding a clock that says you are 140 years old, but every calendar in the world proves the entire world only began 138 years ago. That is the exact dilemma the Methuselah star forced upon us, and solving it has rewritten chapters of stellar astrophysics and cosmic chronology. Let us travel back to the very start of this extraordinary story, to a time when no one knew this tiny star would become the greatest test of our cosmic knowledge. The year was 1912. Astronomers at the Mount Wilson Observatory, led by W.S. Adams, were cataloging faint stars in the constellation Libra when they first documented HD 140283. At the time, it was just another entry in a long list of stars. No one noticed its odd chemical fingerprint or suspected its incomprehensible age. Back then, we had no way to measure stellar ages with precision. No Hubble Space Telescope, no Gaia satellite, no advanced stellar evolution models. The universe's age was a rough guess, and stars were seen as distant points of light, with little connection to the origins of everything. For nearly 90 years, HD 140283 remained in obscurity, a silent witness to the rise of modern cosmology, the proof of the Big Bang, and the first attempts to pin down the universe's true birthday. All that changed in the early 2000s, when the European Space Agency's Hipparcos satellite released its first high-precision astrometric data. For the first time, astronomers could calculate the star's distance with remarkable accuracy, and when they plugged those numbers into basic stellar models, the result left them speechless, roughly 16 billion years old. The universe, by the best measurements of the era, was estimated to be around 13.8 billion years old. A star older than the universe. It was a scientific impossibility, a contradiction that violated every law of physics we understood. You cannot have a child born before their parents, and you cannot have a star formed before the universe that created it. This is when HD 140283 earned its legendary nickname, the Methuselah star, the cosmic rebel that defied time itself. Word of this paradox spread like wildfire through observatories and universities worldwide. Skeptics claimed the measurements were flawed. Believers argued we had missed a critical piece of cosmic physics. Some even wondered if the Big Bang theory, the foundation of modern cosmology, was incorrect. NASA recognized the stakes immediately. If the Methuselah star's age was real, our entire cosmic timeline collapsed. If the measurements were wrong, fixing the error would refine our tools to study the oldest stars and the early universe like never before. So began a decades-long mission to solve the Methuselah mystery, a mission led by some of the sharpest minds at the Space Telescope Science Institute, Penn State University, and observatories across the globe. The core problem was simple to state, but nearly impossible to solve. How do you accurately measure the age of a star that formed mere hundreds of millions of years after the Big Bang? Unlike human ages or tree rings, stellar ages cannot be directly observed. They are calculated using a delicate mix of distance, luminosity, surface temperature, chemical composition, and complex computer models that simulate how stars burn fuel, evolve, and fade over billions of years. For most stars, this works well, but for the Methuselah star, every variable was stacked against precision. Let us break down why this star was so hard to date. First, HD 140283 is a population 2 star, meaning it is extremely metal poor. In astronomy, metals are every element heavier than hydrogen and helium. The Big Bang only produced hydrogen, helium, and tiny traces of lithium. All heavier elements were forged in the cores of massive stars and scattered across space when those stars exploded as supernovae. The first generation of stars, population 3, had 0 metals. The second generation, population 2, has extremely low metal levels. Stars, like our Sun population, I are rich in metals because they formed from gas, enriched by countless generations of supernovae. The Methuselah star's metal abundance is roughly 250 times lower than the Sun's almost pure hydrogen and helium, a direct link to the primordial universe. This extreme metal-poor status makes its evolution behave differently than ordinary stars, throwing off standard models that rely on solar-like composition. Second, the Methuselah star is a subgiant, a phase in stellar evolution where luminosity is extremely sensitive to age. A tiny miscalculation in distance or brightness can shift its age by hundreds of millions of years. Third, early distance measurements had small but critical errors, and astronomers underestimated how the star's unusual oxygen-to-iron ratio affected internal energy transport, a detail that changed its entire evolutionary clock. In 2013, NASA's Hubble Space Telescope delivered the first major breakthrough. A team, led by Howard Bond, used Hubble's fine guidance sensors to conduct 11 precise observations over an 8-year period, measuring the star's parallax, its apparent shift against the distant sky, to a margin of error less than 1%. This pinned its distance at 190.1 light-years, the most precise measurement ever for this star. With the correct distance, astronomers calculated its true luminosity, a key input for age models. They also updated the models to account for helium diffusion, revised nuclear reaction rates, and the star's unique oxygen abundance. The new age estimate was 14.46 billion years, plus or minus 800 million years. While this was lower than the Hipparcos result, it still meant the star could be as old as 15.2 billion years, well above the universe's 13.82 billion year age. The paradox was not solved, but it was refined. Scientists now knew the uncertainty range held the key at the lower end of the error margin, around 13.6 billion years. The Methuselah star fit perfectly within cosmic history. The question became, why were the models still giving conflicting results? Over the next decade, new technology and better physics closed the gap. The European Space Agency's Gaia satellite released ultra-precise parallax data, reducing distance error to nearly negligible levels. Astronomers used interferometry at the Shara array to measure the star's radius with extreme precision, and asteroseismology, studying stellar vibrations to probe its internal structure, a method like using earthquakes to map Earth interior. Revised stellar evolution models, tailored specifically to the Methuselah star's unique chemistry, instead of generic solar-scaled mixtures, brought the age down further. Modern studies from 2024 and 2025, using 3D spectroscopic models and Markov chain Monte Carlo analysis, placed the star's age at roughly 13.6 to 13.8 billion years, with some advanced calculations as low as 12.3 billion years. The paradox was officially resolved. The Methuselah star was not older than the universe. It was a victim of measurement limits, incomplete models, and the extraordinary difficulty of dating the universe's oldest stars. But make no mistake, this star is still one of the oldest known stars with a precisely measured age, a survivor from the first chapter of cosmic time. What makes the Methuselah star so important goes far beyond a solved paradox. It is a living fossil from the early universe, a time when the first stars lit up the dark cosmos, when galaxies were just beginning to form, when the universe was a hot, dense, primordial cloud of hydrogen and helium. Studying HD 140283 teaches us how the second generation of stars formed, how they incorporated the first trace amounts of heavy elements from population 3 supernovae, and how these ancient stars shaped the galaxies we see today. It proves that our cosmic models are robust, even when faced with seemingly contradictory data, and that science advances, not by clinging to certainty, but by questioning, measuring, revising, and chasing precision. This star also reminds us of the vastness of cosmic time. 13.8 billion years is almost impossible for human minds to comprehend. Our Sun is 4.6 billion years old. Earth life has existed for roughly 3.5 billion years. Human civilization is a blink at 10,000 years. The Methuselah star existed long before our solar system was born, long before planets, long before complex chemistry could create life. It has watched galaxies collide, stars explode, and countless worlds come and go. As we stand here today, the Methuselah star continues to shine quietly in the constellation Libra, a humble beacon of cosmic history. It no longer breaks our understanding of the universe, it confirms it. Every observation, every model update, every debate about its age has made astronomy stronger, more precise, and more connected to the true story of the cosmos. It teaches us a timeless lesson. The universe is full of mysteries that seem to defy logic, but with patience, curiosity, and the relentless pursuit of data, we can turn paradox into understanding. We went from a star that should not exist to a star that explains our origins, from a cosmic puzzle to a cosmic treasure. The Methuselah star is not just a relic. It is a reminder that the most incredible secrets of the universe are often hiding in plain sight, waiting for us to look closer, think deeper, and marvel at the infinite wonder of the cosmos. The next time you gaze at the night sky, remember that tiny ancient star, 190 light-years away, a star that once challenged time itself, and now helps us read the universe's oldest story. Please like, comment, share, and subscribe to the channel.